Welcome students to geometry class on this wonderful Wednesday morning, October 9th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's see. Jason, got senior night coming up this Friday, so I hope that goes well. I look forward to coming to game this Friday and seeing you guys play. Quick announcements here. Quiz this Friday. Please don't forget that. Big old quiz. I am discussing right now with Mr. Harmon about you guys possibly attending the Regions Bank speaker who's going to be here Friday during first hour, and I need you to have a good attitude and accept whatever decision I make. I might let you go, I might not. I'm talking right now to Mr. Harmon about what it's going to be about and so on and so forth. So if that does happen, the quiz could be Thursday instead of Friday, but if that happens, I will let you know Wednesday, and of course Wednesday in class. That's actually this video, isn't it? We can all laugh at Mr. Earhart. It's okay because I do these videos a day, sometimes 2 days in advance, and I forget what I'm saying. So I guess I better make a decision now. Let's just hold off, I guess. We've been working really hard. We've had a great semester, or a great 9 weeks, excuse me. And so let's just not have a quiz this Friday. And so either we'll have class on Friday in which you'll take notes, or maybe I'll give you a pop quiz Friday. And if you don't do well, it won't count. And if you do well, it does count. Maybe something like that, but it'll be a no pressure quiz. And then maybe you'll go to that Regions Bank speaker. I'm going to talk to Mr. Harmon about that. So how's that? So let's take the pen here on the Mimeo screen. And as you guys are cheering, I'm sure, let's cross off that quiz on Friday. You do owe me homework. Would you please turn that in at this time? Would you please turn your homework in at this time right now? Thank you. Let's continue on. Again, I go fast on purpose on Wednesdays, especially because I have to teach a lesson and give you a lot of time in class to work on your homework. So let's fly. Okay? And you know, every time I put a sentence up here, you don't have to write it down. Okay? So I just put some sentences up here that I'm reading to you out loud, like this one here. Since it's a Wednesday, we are going to study two topics that you are very familiar with. In fact, students, if you notice, we skipped lesson 4.3. I did that on purpose because lesson 4.4 is more conducive to a Wednesday lesson than 4.3 is. So we will do lesson 4.3 on Thursday. But anyways, you should find these two topics that we're going to look at today pretty easy. Remember, students, the homework I give you on Wednesday is never required to finish. However, I do expect you to work the entire hour until the bell rings. Then tomorrow you will turn in what you did, and whatever you did will be worth 100%. So please keep all of that in mind. Obviously, you did not have to write any of that down in your notes. So let's get started with a lot of excitement. Here we go, and I am going to teach quickly. I want to try to teach this lesson in 15 to 20 minutes and then give you about 20 to 30 minutes to work on your homework and hopefully get it done in class, okay? All right, let's start off with, yep, there it is. You see it. You've had this now for probably since 8th grade, 9th, 10th, 11th grade, Pythagorean theorem. The Pythagorean theorem, lesson 4.4. And if you are big on writing the date down, which I encourage you to do, the date today is the 9th. The date is the 9th. Now I'm going to say this one more time, and hopefully I won't say it again. You're probably going to have to pause the video a lot. I am going to go really fast on purpose. Okay. Anytime you know, I would write this down. It's up to you unless you know this already. Anytime you know two sides of a right triangle, you can find the third side by using the Pythagorean theorem. You should know that pretty well by now. Let's quickly review the names of the sides of a right triangle. And again, students, if you feel like you need to write this down, then do so. If you don't, that's fine. It's totally your decision. Okay? Here we go. This is a right triangle. Okay? Now, whenever you take a line and go straight off your right angle like this, straight across, a dotted line here, the side that you hit is always called your hypotenuse. The other two sides are called legs. So it's just this simple. You want to make it really easy? Find the hypotenuse first, and then everything else, all the other sides are legs. Okay? It's that simple. And the hypotenuse is always the side that's directly across from the right angle. Another way to say it is the right angle always points to the hypotenuse. Okay, so that's quickly reviewing the names of the sides of a right triangle. Now, let's also review what the Pythagorean theorem looks like. Now, most teachers are going to teach this: a squared plus b squared equals c squared, and that's totally fine. And one of the reasons they use those letters is because of a geometric proof in which you use those letters in proving Pythagorean's theorem. For my students, I like to have you use this instead of a squared plus b squared. I always tell my students leg squared plus leg squared equals hypotenuse squared. That way there's no confusion on which of these variables stands for a leg and which of the variable stands for hypotenuse. But the reason I want you to see this is most textbooks and most colleges and the ACT test, if they're going to give you a problem dealing with Pythagorean theorem, it is going to use, more than likely, a squared plus b squared equals c squared. In this class, though, I'm going to use leg squared plus leg squared equals hypotenuse squared. Okay, let's continue on. Now, I want us to quickly do two problems, and then we'll jump on to our next topic, okay? What I'd like us to do is I want you to copy these in your notes, please, if you would. And let's go ahead and let's find the missing side to this triangle, and then find the missing side to this triangle. Now, we'll come over here. Here are the right angle points across, so this is my hypotenuse. So my other two sides are my legs. Now, I know two sides, so I can very easily find the third side of a right triangle. Remember, Pythagorean's theorem only works on a right triangle. I can very quickly find the third missing side using Pythagorean's theorem. So one of my legs is 2, so 2 squared. One of my legs is 3, so 3 squared. By the way, it doesn't matter where you put the 2 and the 3, they're both legs. And then my hypotenuse is x, so I'm going to put x squared. Now, 2 times 2 is 4, 3 times 3 is 9, so 4 plus 9 is x squared. And then, let's see, 13 would equal x squared. And now think about this, students. I do not want to know what x squared equals. I want to know what x equals. So I'm going to take the square root of x squared, and the square root of x squared is x. However, if you take the square root of one side, you must take the square root of the other side. So when I do that, you're used to putting plus minus in front of the radical. Don't do that, because we're dealing with the length of a side of a triangle, and length is never negative. Now I'm going to be honest, students. I'm sitting here at my computer without a calculator, and so it's really difficult for me. I'm all wired up here with my headset, so I'm not going to get up. But you guys can type the square root of 13 on your own into your calculators, and you should get, let's see, 3 squared is 9, 4 squared is 16, 13 is, you should get approximately 3.6 or 3.7 rounded, okay? So go ahead and type in the square root of 13 into your calculator, and you should get either 3.6, 3.7, around in there, something like that, okay? All right, I hope that helps. Let's go ahead and try the next problem. Copy this in your notes, please. We have a right triangle in which we know two sides, the length of two sides, 8 and 11. Well, let's see, this is a leg. This is a leg. This is my hypotenuse. So using Pythagorean's theorem, L squared plus L squared equals 8 squared, I can solve for x. Now one of my legs is 8, so 8 squared. My other leg is an x, so x squared. And my hypotenuse is 11, so 11 squared. Now 8 times 8 is 64 plus x squared. 11 times 11 is 121. Now we want to get x squared by itself, so we bring the 64 over. It's a positive 64. And when we bring it over, of course, it becomes a negative 64. So now I'm going to continue the problem up here. Now I'm left with x squared equals 57. 57. Now, I want to find what x is, so I'm going to take the square root of x squared, which gives me x. However, if you take the square root of one side, you must take the square root of the other side, which is the square root of 57. Again, I'm going to try to round this in my head, okay? 7 times 7 is 49. 8 times 8 is 64. 57 is 8 away from here. 7 away from here, so it's a little further. I'm going to guess it's something like this, students. You're probably getting approximately 7.5, 7.4, 7.5, or 7.6, around in there when you type in the square root of 57, okay? All right, I hope this is making sense. This should be old review stuff for you guys. All right, let's finish up today with the distance formula, lesson 4.4. The date is still the same. Let's take a look at something called the distance formula, lesson 4.4. Now, when you are given 2 points on the coordinate plane, you can find the distance between these 2 points by using the distance formula. So if you got a coordinate plane like this, and you got an ordered pair here, and an ordered pair right here, and you connect those 2 dots, you can find the distance between those 2 points using something that we call the distance formula. Here is the distance formula. Are you ready? Write this in your notes. It's a real long square root, and then you write a parentheses, and you write x minus x, then you close the parentheses, and you square it. Then put a plus sign, then write a parentheses, and then you write y minus y, and then you close the parentheses, and then you square it. And of course, all of this is under the square root, okay? There you go. You just wrote down the distance formula. So you've got it, and now we're ready to use it. Let's do 2 problems, and then we'll be finished with the notes today. All right, here we go. All right, in your notes, I would encourage you to very quickly draw a coordinate plane. Put a point at -2, +2, so we went over 2 and then up 2. And then also put a point at +6, +5, so we went over 6 and then up 5. +6, +5. And what I would like you to do is I would like you to find the distance between these 2 points. Find the distance between those 2 points, okay? Now, because I really can't do a lot of work with this grid in the way, I'm going to go ahead and just remove the grid. So there. Now there's my line with the ordered pairs, and now here's the formula we're going to use. So easy. X minus x, quantity squared, plus y minus y, quantity squared. Now this is your x, this is your y, this is your x, this is your y. And students, it doesn't matter which x you put in first, and it does not matter what y you put in first. It does not matter. So I have x minus x. So my first x here is -2. And then minus, and then my next x is 6. So -2 minus 6, quantity squared. Then bring down your plus sign, and then y minus y. Well, here's your first y, it's 2. And then my second y is 5, so 2 minus 5, quantity squared. All right, now we're going to finish this right up here. Okay, if you're bad with your sign numbers, then use your calculator. Nothing wrong with that. A -2 and a -6 would be a -8 squared. And a 2 minus 5 is a -3 squared. Now, if you're going to use your calculator to square these numbers, you better put parentheses around the negative numbers, or you're not going to get out the right answer. Okay? If you just type in -8 squared and hit enter, your calculator is going to say -64, and that's not right because you're squaring the 8 and you're also squaring the negative sign. So a -8 squared really means a -8 times a -8, which is a +64. And a -3 times a -3 is a +9. So 64 plus 9, which would be 73. So again, I'm going to have to estimate this since I don't have a calculator. The square root of 73 would be, let's see, 8 times 8 is 64, 9 times 9, 8 times 8 is 64, 9 times 9 is 81, 73 is 9 away. I would say it's going to be something like 8.3, 8.2, 8.3, or 8.4, around in there when you type that into your calculator. Okay? So you just found the distance between those 2 ordered pairs. What is that, Mr. Earhart? Feet, inches, yards? Well, it depends, guys. Let's go back a page real quick. Look. It all depends on what your grid was. Were these grids inches long, feet, yards? We really don't know, so we just say it's units. But that's why we really don't know, because we're not sure what unit of measurement the coordinate plane was in. Okay? So we just say 8.3 units is the length. All right, moving on to our last problem. Go ahead and copy this in your notes if you would, please. I would write a coordinate plane. I would plot a point at -5, +4, and then -1, -3. All right, so go ahead and copy that in your notes. -5, 4, and then -1, -3. Now we're going to find the distance between those 2 points. And of course, because I don't want this grid, I've went ahead and rewritten it without the grid. So there we go. Now, using your distance formula, Let's find the distance between these 2 points. This is your x, this is your y, this is your x, this is your y. Let's start with x minus x. That would be -5. Now watch your signs here. -5 minus, and then look what you have for x, a -1. So you've got a double negative. -5 minus a -1 squared plus, then you have y minus y, so 4, here's your y, and then minus, and then be careful, it's a -3, so 4 minus -3 quantity squared. Now, -5, again, use a calculator if you're weak with your sign numbers. Don't be embarrassed to do that. -5 minus a -1 is -5 plus 1, and that would be -4 quantity squared. Plus, and then 4 minus a -3 is 4 plus 3, that's 7 squared. Now let's go ahead and let's simplify this. Now watch your signs here. It's not just 4 squared, it's -4 squared. So -4 times -4 is a positive 16, and 7 times 7 is 49. There we go. Well, if you add those together, you get the square root of 65. Now again, I'm going to have to do my rounding up here. 8 times 8 is 64, 9 times 9 is 81, we have 65. I'm going to guess you're going to get 8.0 or 8.1 if you type this in correctly and round to 1 decimal place. Okay? So, hey students, there we go. We're finished with your notes. I told you we go fast today. I hope you're understanding this. It's not too difficult. I wish we had time to go into where the distance formula comes from. I will show you this very quickly. The distance formula comes from this. If you were to draw a right triangle like this, and then use Pythagorean's theorem, you would find this length here by subtracting your 2 y numbers and then square it, and you would find this length here by subtracting your 2 x numbers and squaring it. So basically when you use the distance formula here, you're really using Pythagorean's theorem. You really are. You just don't realize it. Okay, here's your homework assignment. You do not have to finish this, but you will turn in tomorrow what you get done in class today, and I'm trusting you to work the entire class period. Please don't talk and goof off. Get your homework done as much as possible. I don't mind telling you that I'll give you 2 bonus points if you get it finished. The only problem is I don't think you need the bonus points, because once we take a quiz, we cancel out all of your bonus points. I think you guys have quite a few already, but if you don't and you want to earn some bonus points, feel free to take 2 bonus points if you finish the entire assignment. Okay? Hope you guys are working hard. Hope you're doing well. Please call me or email if you have any questions.